I think it's time to start before even more people try to get into this room. Welcome to this seminar to all of you. In particular, welcome to our main guest, Professor Emeritus Martin Pall. Professor Pall has a broad scientific background in biochemistry, genetics, molecular and cell biology, and in medical topics. And he even has a degree in physics. In 2013, Professor Pall published his very first paper on how electromagnetic fields, EMFs for short, influence the cells of our bodies, and already less than a year after, he is invited to many countries to present his findings. This paper of his from previous year and the ones that now follow may have a heavy impact on how we will think about electromagnetic fields, health and the environment in the coming years. The reason for that is simple. If Professor Pall is right, the entire foundation for this document, which is now the platform for Norway's radiation administration, is wrong. I shall leave to Professor Pall to explain his subject further. He will definitely do that much better than I would. After that, we should come back to its implications. So, after my brief introduction, we will have Professor Pall's presentation, which will take 45 to 60 minutes, 45 minutes or so, I hope. Then there will be a discussion. Around 2 o'clock, the meeting will end, but you are encouraged to continue informal discussions here in the room for still some time. This seminar came about at my personal initiative. I have been in the telecom and ICT business for some decades, and when I retired, I decided to follow up on something that has plagued me evermore. I understood that something serious was wrong about the radiation part. The seminar is arranged in cooperation with the Arne Næss seminars at the University of Oslo. In the spirit of the eco-philosopher Arne Næss, the Arne Næss seminars have a tradition of bringing together opposing views for fruitful dialogue in an atmosphere of positive will for understanding. The seminar today shares that same ambition. That is a challenge to all of us, since when it comes to electromagnetic radiation, the fronts are extremely polarized. The two camps cannot even agree on seemingly objective facts, like whether there is or is not a rise as to the numbers of brain tumors in Norway. That would not be so serious were it not for the fact that they cannot either agree as to whether the kinds of radiation that we have from radio communication, cell phones, Wi-Fi and the like can possibly have any impact at all on humans, not to speak on other living organisms. The one camp, which I would for sure call the dogmatic radiation establishment, tells us that there is simply no way our bodies can be affected. And they tell us that, if you want to enter the room, just please come forward and you would have to bench or to sit on the floor. Yes, and they tell us that there is simply no way our bodies can be affected. And they tell us that there exists no scientific explanation, that is, no mechanism, for how such an impact should possibly come about. For example, the expert panel evaluation report, this one, delivered to the Ministry of Health from the Norwegian Institute of Public Health, repeatedly states this. In it, each and every research report that finds negative health effects is either discarded or discredited because of some methodological weakness, or because the findings cannot be possible, as there is no mechanism for it. It is this that Professor Pall is challenging. At the other end of the spectrum, we have, let us call them for short, the tinfoil hat people. They claim that there must be something because they feel it. The tinfoil hat people are desperate from their sufferings, from being accused of being hypochondriacs, or subject to nocebo effects. I have received personal letters from people who spend their lives trying to hide away from radiation. Letters on paper because they cannot use email. They fight for their health as well as for their self-esteem, and against what they see as a toxin that cripple them and that will have long-term impact on us all. Neither does that camp have any scientifically proven mechanism to underpin their claims, nor their personal experiences. Nor have the many scientific studies they refer to any explanation as to how it could possibly be that living organisms could be affected from radiation. It should not continue that way. Let us all, for once and together, break out of this pattern and just listen to a person who will explain what he has found to be just the mechanism that both camps have been lacking. Then let us, as academic discussions should go, come up with all the questions we need to properly evaluate the validity of these findings together. Professor Pall, I look forward to listening to you. The floor is yours.
So, what I'm going to talk about today, so we have is how electromagnetic fields act, and they act through activation of some channels, which are called voltage-gated calcium channels, and specifically through some things called L-type voltage-gated calcium channels. And that's probably not going to mean much to many of you, but it hopefully will mean a lot in a few minutes. And this then leads to many impacts on health, and one of them is EHS, which I will talk about, although only relatively briefly, but also other impacts on health. And I think what I'm hoping you will see from this is how all this fits together, because this whole story, I think, has developed with extraordinary rapidity and has given us some very important insights into how these fields act. Okay, so so the central question is, how can electromagnetic fields impact our biology and medicine, for better or for worse? These are usually abbreviated EMFs in English. So these EMFs are composed of low energy photons. That is, the individual photons that make them up have very low energy. And in fact, they're such low energy that they cannot influence the chemistry of our bodies. So then the question is, how can they influence our biology? And so how can they produce what are called non-thermal effects? That is, effects that occur independent of any heating and only at very, very low levels of heating. The safety standards, and that's true both for U.S. and international safety standards all over the world, assume that they cannot produce anything other than heating, that only thermal effects need to be considered, and that there cannot be biological effects independent of those thermal effects. But there are literally thousands of papers in the scientific literature reporting biological effects at exposures well within safety standards, which should not occur if the safety standards are correct. So how can we understand these? Well, let me just say, first of all, there are other types of evidence which also argue against heating as the primary mechanism. And it's been known, for example, that pulsed electromagnetic fields are often much more biologically active than non-pulsed fields, even when they produce the same amount of heating or even less heating than the non-pulsed fields. So again, that argues compellingly against heating or the thermal effects as being the primary mechanisms, okay? And so, okay, so how then do we solve this great puzzle? How can these things work to influence our biology? And when the energy per photon is too low to affect the chemistry of our bodies. And so what I found, and this was based on evidence in the literature, was that these EMFs activate these voltage-gated calcium channels. These are channels which are blocked by calcium channel blockers, okay? So the key piece of evidence, which is discussed here, is that you can block all the effects in these studies by using calcium channel blockers, and that tells you that the entire mechanisms work by activating these voltage-gated calcium channels, okay? So what I'm going to do first is to provide some of the evidence supporting this mechanism, and then we're going to talk about other things that also support the mechanism in other ways. So what we have here is a table which talks about different kinds of fields. Here's a pulsed electromagnetic field which activates the L-type channels. How do we know that? Because the calcium channel blockers that block the L-type channels block these effects. And this was done with human lymphocytes, and it changes the two things that were being studied here: cell proliferation, cytokine production. Static magnetic fields can also work this way. And let me just say, it's actually an interesting story about how this could be produced, and I won't talk about it unless it comes up in the question session. But these can have effects, and here's a couple of them, and you can block the effects with calcium channel blockers. Extremely low frequency fields, like the fields we get out of our wiring, 50 hertz, 60 hertz, also work in the same way. Here's another electric field effect, and so forth. Static magnetic fields, so here's NMR, which is a microwave effect, so microwave frequency. This one was a microwave frequency one too. Microwaves in general are a minority of these, but they're obviously the ones that we're most concerned about because of the great increase in exposures that we've had over the last 3 decades. It seems to keep going up every year with new devices coming in that are exposing us to these microwave fields. So we have NMR, we have static magnetic fields. Here are very short microwave pulses, and they work through these L-type fields. And again, another very short pulse, and so forth. And there are other ones that are not listed in this table. There are at least 3 other ones that have been published since since I first wrote this paper back around the beginning of 2013. So. And let me just say, there are other channels that are involved. Okay, so in a few cases you have T-type ones, and if I go back, you'll see they're N-type, P/Q-type ones, N-type. So I'm not going to talk about how these differ, but most of our interest is in these L-types, and I'll tell you a little bit about why that is later on. Okay, so those are studies. Every single one of those studies challenges the heating paradigm. Why? Because they say that the effects go through these channels, not through heating. okay? And you can therefore block the effects with channel blockers. But it's also true that there are many, many other studies that support this view. And so there are hundreds of studies that have shown that microwave EMF exposures are followed by changes in calcium fluxes. So, you know, whenever you open those channels, you get a flux of calcium, and I'll talk about that in a little bit more detail shortly. And you also get changes in calcium signaling. So the calcium in the cell has important signaling properties. It can produce many changes. You know, if you have excessive calcium signaling, that can cause pathophysiological damage. That can cause things that are involved in diseases. Now, one of the things that I didn't know when I wrote this paper, but that's very important, is that Dimitris Panagopoulos and his colleagues in Greece published two papers, one in 2000, one in 2002, in which they talked about the fact that they could do biophysical modeling of these channels. And they predicted, based on biophysical modeling, that these channels were attractive targets for the EMFs. That is, that these very low energy fields could act, based on the biophysics, could act to activate these channels. Okay? Now, they were looking not only at these voltage-gated calcium channels, but also at other voltage-gated ion channels. Okay, so there are other channels that, instead of letting calcium flow into the cell, allow other ions, and they thought that any of these could be involved. Let me just say that the voltage-gated calcium channels, the VGCCs, are the only ones so far that I've seen evidence for in responding to these fields. Now, that doesn't mean that there won't be evidence further down that other things may be involved, including some of these other voltage-gated ion channels. But so far, I'm not seeing any evidence for them. All of it seems to go through the VGCCs, and I'll show you some information about that. Again, we have to keep our minds open on that. There may be other targets, but so far there is no clear evidence that there are other targets. So now, I think it's important not only to know that Panagopoulos and his colleagues you know, showed by biophysical modeling that these were plausible, but I think it's important to understand why they were attracted to these channels as potential targets for these very low energy fields. Okay, and so because it gives you a feeling for why these things are important, you know, why they have these roles in our bodies. And so there are three main facts here that are important that you can see why they were attracted to them. One is, we know that the fields exert forces on charged groups. So if you have a positive or negative charge groups, these fields can push them and pull them. It can move them, okay? It can produce forces on them. And in fact, that's the way microwave ovens heat your food, okay? The way a microwave oven heats your food is that there are charged groups in your food. They may be totally charged or partially charged, and they get joggled around in the field very, very rapidly. And that then generates heat in your food, and the heat then cooks the food, okay? That's the way microwave oven, this has been known since about the time of World War II, that these microwave fields can act in this way. So all of these fields, I mean, not just the microwaves, but also the other fields made up of these low frequency photons, can act by putting forces on charged groups, okay? The second fact, which is very important, is that these channels, the opening and closing of these channels, is controlled by charged amino acid residues. So there are charges in the proteins that are pushed or pulled, and they can then open the channel or close the channel, okay? So we know those charge groups are very important in controlling these channels. And the third fact is that we also know that very modest forces on these charge groups, which are produced by changes in the charge across the plasma membrane, that those can in fact open and close and close the channels, okay? So what that means is that these very weak fields, which are, which produce only very modest forces on these charges, can open and close the channels. And that's basically where the biophysical modeling comes in. Panagopoulos and his colleagues showed, yes, indeed, these very weak fields can do that based on biophysical modeling, okay? So this whole thing makes great sense, that weak electromagnetic fields, as shown in that table, can then lead to activation of these channels. And as I say, they've done this mathematical modeling which supports this view. And so it seems clear then that these channels are responsible for a large number of biological effects in response to these fields, okay? Now I want to talk to you a little bit about how these channels work, okay? So these voltage-gated calcium channels, the VGCCs, are channels in the plasma membrane of cells. So all cells have an outer membrane, a plasma membrane, right? And these channels occur in the plasma membrane. And when they open up, they allow calcium to flow into the cell. And it's the excess calcium in the cell which is responsible for most of the biological effects, okay? So you get lots of calcium in the cell, and that, that produces then the changes that are seen. And there are a lot of effects that are produced by this excess calcium. These effects are called downstream effects, so they're sort of indirect effects that occur along different pathways. And we'll be talking about some of those very shortly. Now, the advocates of the current safety standards still claim there is no biophysically viable mechanism for these weak field EMFs to produce non-thermal effects in our bodies. And they're simply wrong about that, and they're wrong for the reasons that you've just seen, okay? So you will no doubt see them even after this making this claim, and it's simply a false claim, okay? Now, the finding that EMF exposure acts by activation of VGCCs is obviously an answer to the puzzle of how these EMFs that are composed of low energy photons can affect us. And I want to emphasize the fact that it's the fields as a whole that are responsible for opening and closing these channels. It's not the individual low energy photons, okay? It's the fields as a whole that produce these forces on the charge groups and regulate that. Now, when you increase intracellular calcium, one of the things that happens that's quite important is you increase the synthesis of nitric oxide. Nitric oxide is NO, okay? And you do that because two of the enzymes that make nitric oxide, enzymes that are called nitric oxide synthase, are calcium-dependent enzymes. So they require elevated calcium in order to work to produce nitric oxide. And so when this calcium flows into the cell, it activates those enzymes, and you get a lot of nitric oxide. And so a lot of the effects go through nitric oxide, but there are also some effects that occur independent of that. In one of the important studies, I think, that was published, this was published a couple of years ago by Arthur A. Pilla, and I'll talk about some of his work later on in addition. He showed that pulse microwave frequency EMFs could produce, and these are in cells in culture, so you have cells in a petri dish, basically. So these are mammalian cells in culture, could produce almost immediate increases in intracellular calcium. Intracellular calcium is often designated in this way. And also in nitric oxide synthesis. And all of this occurs in less than 5 seconds, okay? And you can measure the nitric oxide by using a nitric oxide electrode that you sort of put over in the gas phase over this culture. And so in less than 5 seconds, you get increases in calcium, you get increases in nitric oxide, and that nitric oxide diffuses up into the air above the cells, and you start measuring it, okay? So this is obviously very quick. And so this basically, gives you a very nice experimental system for looking at the kinds of things that we just talked about, okay, and sort of putting it all together. Now, this is a figure now that kind of summarizes much of how I think this whole thing works, okay? So here we have the microwave and other lower frequency EMFs, and they activate the VGCCs, the voltage-gated calcium channels, and that then increases intracellular calcium, and that then increases nitric oxide, okay? And so then there are several things that can happen. One is that nitric oxide has a signaling pathway in the body. This is the normal function of nitric oxide in the body, works to increase the level of what's called cyclic GMP, which then stimulates a protein kinase, which I've abbreviated G kinase here. And we think, and when I say we, I mean both me and also Arthur Pilla, whom I mentioned before, think that therapy works by this pathway, okay? There are therapeutic effects of these fields under very highly controlled specific conditions. They can be useful medically. And the one that's been most studied is the stimulation of bone growth, which I reviewed in my first paper. And that goes through this pathway, okay? So, there can be useful things that can be produced. There are also a lot of pathophysiological effects, damaging effects, and they go through these things, okay? So one of the things that nitric oxide does is it can also react with another compound called superoxide to form peroxynitrite. That's ONOO-. That's the structure of peroxynitrite. It's a potent oxidant, and so it can produce a lot of oxidative damage. It is not a free radical, but it can break down to form free radicals, and they can also have effects. And both the peroxynitrite and the free radicals can produce what's called oxidative and nitrosative stress, which leads to a depletion in the antioxidants in the body. And so that can produce pathophysiological effects as well, okay? So we think a lot of the disease effects go through these things. But in addition, there are calcium signaling pathways. So calcium can trigger a number of other changes independent of nitric oxide. So not this, but other mechanisms. And if you have too much of those, you can also get pathophysiological effects, okay? So all of those things, I think, are explanations for some of the diseases that are produced by this. And so we'll be talking about those. So basically, again, the therapy goes through this pathway. The pathophysiological effects go through some combination of these, and we'll talk about very briefly some specific examples for those. Okay, so let's see, that one we don't need. Okay, so Pilla, as I think I mentioned before, published a model of how he thinks therapeutic effects work, and it's very similar to what I just described to you. And I also proposed at the same time looking specifically at stimulation of bone growth, which is the most highly studied therapeutic effect, that it went through that pathway. Okay, and so we're in I mean, his model wasn't identical to mine, but it's very similar, and the two are clearly compatible with each other. So, okay, and so here, so here he states non-thermal electromagnetic fields from first messenger to therapeutic applications. So Pall is an expert on therapy. He's been working on this for over 40 years. He's certainly one of the world's great experts on this, and he says these are non-thermal. And many other people do as well. So the therapeutic effects are clearly non-thermal. They should not occur according to the current safety standards, but they do. Okay. So, and there's something like 7,000 papers on therapy in the literature. Okay. You can't ignore this stuff, but some people do anyway. So, okay. So my paper, the first paper I published was in this journal. Journal of Cellular and Molecular Medicine, and it was, as I think Einar mentioned, honored to be included in on the Global Medical Discovery site as one of the most important medical papers of 2013. And I've published two other papers, one talking about therapeutic effects and the work of Pall and also my interpretations and how they basically fit together. And then there's another one that talks about a lot of different things, including disease effects and how we can develop biologically relevant measures of damage. And then I'm also going to talk a little bit about my work on multiple chemical sensitivity, because I think that it's very important in terms of understanding EHS. Okay, so EHS and multiple chemical, and so this is usually abbreviated MCS. EHS and MCS have many similar properties, and I'll talk about those when we get to that stage. Okay. So, health impacts by microwave radiation. There are multiple studies showing that each of the following responses have been reported to be produced by microwave radiation exposure, and so what I want to do is to talk about that, and also the fact that none of these can be explained by heating. Even the one thing that the heating advocates claim can be explained by heating, it's simply not true. And so we have, what you see here is these have been reported repeatedly, so I think the evidence is quite strong. Obviously, some people in industry will challenge that, and so don't be surprised about that. But let's talk about some of these. Okay, so first of all, oxidative stress has been reported in close to 1,000 studies in response to microwave exposures, low-level microwave exposures. And of course, I argue that that's due to proxy nitrite and free radical formation producing oxidative stress. And then there are also effects to produce single-strand breaks in cellular DNA and also double-strand breaks in cellular DNA. And we know that these can be produced by free radical attacks on DNA. And so that's and as I said before, you get these free radicals when proxy nitrite breaks down, and those then can attack the DNA and produce these single-stranded breaks in DNA. And whenever you have a lot of single-strand breaks in DNA, you also get double-strand breaks in DNA, because whenever you get two breaks on opposite strands that are near each other, they fall apart and you have a double-strand break. Okay, and so both of these have been reported repeatedly in the literature. And then there's cancer. Cancer, I think, can be produced by quite a number of different things, including single-strand and double-strand breaks. you get changes in the DNA, including 8-nitroguanine, which is produced from peroxynitrite, and other changes in the DNA that can occur. And let me just say the following. Okay, so one of the questions about cancer is, well, how can cancer be produced by these low energy, low frequency fields? And so and one way of asking that question is to look at other situations where we know cancer can be produced and ask, what do we know about how it's produced under those circumstances? And one of the circumstances that's been studied a fair amount is what's called inflammatory carcinogenesis. So when you have chronically inflamed tissues, it's been known for at least 30 years that you tend to get higher rates of cancer in those tissues. And it's been shown that that is produced by elevated levels of nitric oxide and peroxynitrite. Okay, so we know that these things can produce cancer in that situation. And so basically, I'm arguing, well, cancer in this situation is probably produced by very much the same mechanism. Okay, and let me just say one other thing about this, because I think it's important. The advocates of the current safety standards have argued that ionizing radiation, X-rays, gamma rays, and so forth, are very different from these fields that are made up of low-energy photons, because the photons making up the ionizing radiation are extremely energetic. And these photons have very low energy. And that's absolutely true. Okay? That's true. But what's also true is that the downstream effects of both of these fields produce a lot of free radicals, which are responsible for many of the effects. So the ionizing radiation produces these free radicals through what's known as Compton scattering. This was discovered by Arthur Compton, who got the Nobel Prize back in 1927 for studying this stuff. And so we know that that's true, and we know that those free radicals are involved in producing cancer in ionizing radiation exposures. Okay, so when you get ionizing radiation, you get cancer through those free radicals. Okay, and we're getting free radicals by a different mechanism. So the effects of the fields, even though the photons are very different, the effects of the fields are not that much different. Okay, they have a lot of similarities because they can both produce large numbers of free radicals that then have biological effects. Okay, so again, the simplistic view that the advocates of the current safety standards give is that, well, the photons are very different, and they are, but the effects of the fields are not so different. Okay, breakdown of the blood-brain barrier is another thing that's been shown to occur in many different studies. And we know that when you have a lot of peroxynitrite, it activates some enzymes called matrix metalloproteinases. So you get increased proteinase activity, and that then leads to, and I apologize for the complexity of this, but I'm trying to give you a feel for what's going on here, okay? That when you have in the blood-brain barrier, there are things that tie the cells together in the vasculature that goes through the brain. These are called tight junctions. So they basically very tightly tie the cells together in the blood vessels. And by degrading those with these MMPs, you break down the blood-brain barrier, and it becomes very permeable. Okay, why is that important? Well, for one thing, it makes the brain much more sensitive to chemicals that can get to it, and also to infectious agents that can get to it. So that can be important as well. Male and female infertility has been found, and that's probably produced by both double-strand breaks in DNA, but also other mechanisms. And You can get what's called apoptosis if you have enough intracellular calcium, which can kill off cells and cause infertility for that reason. Okay. Let me just say, these areas probably more complicated than what I've got here, but basically we do have plausible mechanisms that can produce male and female infertility in response to these fields. Okay, so therapeutic effects we've already talked about. I won't say anything more about that. There are reports of diverse neuropsychiatric symptoms, including depression, but including many other things. And so how do those get produced? I think that they get produced simply because the VGCCs have a role in the release of almost every neurotransmitter in the brain. Okay, so when your brain has a lot of VGCCs in them, in the neurons, and also in the glial cells, and so when you activate those, you're going to stimulate the release of these neurotransmitters that trigger activity in the brain. You cannot predict what's going to happen with this because the brain's so complicated and there's so many different neurotransmitters there. But you certainly can predict there's lots of changes that are going to occur. And so it's not unreasonable then that you're going to get diverse neuropsychiatric symptoms. It's also been reported that you may get neurodegenerative diseases from this as well, which is not discussed here. So, there are lots of things that can happen. They're very complex, and it's, as I say, difficult to predict what's going to happen. But there are a number of studies that have shown that that there are a lot of things that happen. And melatonin depletion. So melatonin, of course, is a sleep hormone. That the levels go up early at night and help you go to sleep. It's been shown that melatonin levels basically almost drop to zero. There's very little melatonin in people exposed to these fields. And we think that that works mainly through calcium signaling in the two ways that are discussed here. Cataract formation is another thing which is interesting. Let me just say the advocates of the current safety standards have argued that cataracts are formed by heating. Okay, in fact, there's compelling studies that show that that's not true, and there are also studies that have shown that increased intracellular calcium has an essential role in cataract formation, and that excessive VGCC activity can then cause cataracts. So I think it's clear that the views that the advocates of the current safety standards are arguing with regard to cataract formation is simply not supported by the scientific evidence. We have, in addition, an unexplained epidemic of electrical changes in terms of the electrical control of the heart, and specifically, we have increased prevalence of tachycardia. Tachycardia is very rapid heartbeat, okay, and arrhythmias, which where the heartbeat is highly irregular, and arrhythmias often lead to sudden cardiac death. So these are obviously very serious issues. Now, what's interesting is that these have been going up at the same time that ischemic heart disease, which is the standard stuff that we're always told to worry about, has been going down. Okay, so this is not caused by ischemic heart disease. I think it's probably caused by EMFs. No doubt some people will argue about that. Why do I think that? I think it basically because the pacemaker cells in the heart, they're found in what's called the sinoatrial node, have very high densities of these VGCCs. So they're very susceptible to anything that activates the VGCCs. And so I think that's what's happening here, is that these fields are activating the VGCCs, and producing increased intracellular calcium, and these are what are producing the changes in the heart. So I believe this is a direct effect on the heart rather than an indirect effect. Some people have suggested it's affecting the nervous system, which then indirectly affects the heart. But it's been shown in studies going back to the late 1960s that you can take isolated animal hearts and expose them to microwave fields at levels that are well within our current safety standards and get them to respond with tachycardia, very rapid heartbeat. Okay, and let me say, Dr. Magda Havas has shown that this kind of response is highly elevated in some, but not other, of the EHS people. Okay, so everybody doesn't have this that has EHS, but some people do. And she was able to show that the people who do, if you take a cordless phone and turn it on and off, and the person doesn't know when this thing is happening, when it's being turned on and when it's being turned off, a cordless phone can produce, in the people who are most sensitive, essentially instantaneous tachycardia. So the heartbeat goes from boom, boom, boom to boom, 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 boom. And then you turn it off and it goes right back to where it was before. Okay, so it's really quite stunning, and the effects are quite important. And so let me just say, I will talk very briefly, if I have time anyway, about why the EHS people don't all have the same symptoms, why there are differences among the population of EHS people. Okay, so basically, all of those things that we just talked about go through these pathways that we've discussed. Okay, every single thing can be explained through the activation of VGCCs, calcium, nitric oxide, etc. And let me just say, I am open to the idea that there may be other targets of these fields. So far, I haven't seen any evidence for it. Okay, all of the evidence so far can be explained as being a consequence of the VGCC activation. Okay, again, this may change over time, and I think we need to keep our minds open to possibilities. But so far, in looking at these studies, I haven't seen any evidence that anything else is involved. Okay, and I certainly haven't seen any evidence that heating's involved. Okay. So let's talk about EHS. And so cases of EHS. Okay, so cases of EHS are thought to be caused by previous exposures to EMFs, particularly microwave and radio frequency EMFs, but not only. And I'm going to talk about the similarities with MCS. Okay, so multiple chemical sensitivity. And let me say, I think we know a lot more about MCS than we know about EHS. And so what I'm going to do is to argue by inference, so that these two are probably quite similar, and that tells us what the probable mechanism of EHS is, but it doesn't tell us for certain that that's right. Okay? So, okay, so what do these things have in common? Cases of each are thought to be initiated by previous exposures, particularly chemicals in the case of MCS and EMFs in the case of EHS. Such exposures can then cause high-level sensitivity responses. MCS and I'm sorry, that should be EHS. This is a mistake on my part. MCS and EHS are often comorbid. That is, they often occur in the same individuals. Not always, but fairly often. Okay? Both involve symptoms coming from the brain and coming from peripheral tissues. I just talked to you about a peripheral tissue thing, the heart, okay, that we talked about just a little while ago. Okay? There are other peripheral tissues that can also be impacted. In both cases, both of these sensitivity, I mean, I call them diseases. Obviously, some people call them syndromes, whatever you want to call them. So so you have both symptoms coming from the brain and symptoms coming from the peripheral tissues. So peripheral tissues, everything outside the central nervous system. And then there's a lot of variation in symptoms from one individual to another in both, okay? And I think that that's because there's a primarily local mechanism which is involved. And so depending on where that local mechanism, what parts of the body that local mechanism has been turned on, you get different responses, okay? So everybody's not the same, and that's exactly what we predict will be true because of this local mechanism, okay? So chemicals act in MCS by stimulating, and they work along different pathways to do this. So almost all these effects are indirect by stimulating what are called NMDA receptors, okay? So these are receptors for glutamate, and they are responsible for something called excitotoxicity. And it turns out they have very similar properties to the VGCCs, okay? And so let me say, we not only have these pathways that show how these things can act to increase the NMDA receptors, but we also have studies from animal studies that show that the toxicity of members of each of these groups, and these are not the only things that can do this, but you can lower the toxicity by using an NMDA antagonist, by using a drug that lowers the activity of these NMDA receptors, okay? So we know a lot of the toxicity goes through this mechanism. And I hope I'm not losing everybody here. It's, some of these, and let me give you a little story here, okay? We scientists, we read a lot of papers, right? I'll tell you a little secret. It's very rare that we understand everything in the paper. But you don't have to understand everything in order to get useful things out of it. And so you look for the things you do understand and what those things tell you. If there are other things that you don't understand, then you got to work on them. But basically, you learn how to glean information about what things are really solid and what things are not. And so I'm presenting to you a lot of information, and a lot of this I know is going to go over your heads. But I think you can also see how these things fit together, and you can kind of get a feel for what things are really solid and how that, what kind of important lessons they tell you. And so that's why I'm giving you all this information. Not that I expect you to be experts on this thing, but that it tells you important things about where we are in this whole process. Okay, now the NMDA receptors and the L-type VGCCs, which are the important ones here, have many things in common, okay? So both of them open up an ion channel when they're activated, okay? So they open up a channel. Both of them stay open relatively long time periods, and that's important because it means that there can be a lot of ion flow into the cell as a consequence of that. Both of them allow calcium to flow into the cell, and both of them create their effects through excessive levels of intracellular calcium, okay? They both lead to production of large amounts of nitric oxide, NO, through the action of these two calcium-dependent enzymes. And NO often leads to the production of peroxynitrite, okay? And this sixth one is perhaps the most complicated of these, and that is the following. And this has to do with a mechanism known as long-term potentiation, which is involved in increasing the sensitivity of the synapses in the brain, okay? So when you have synapses, sort of talking to each other, one of them triggers the other one, these synapses can become more sensitive or less sensitive, depending on how they're regulated. And it turns out that long-term potentiation increases the sensitivity of these synapses in the brain. And what that means is they make the brain more sensitive to anything that starts triggering these neurons, okay? So immediately say, hey, that's an interesting mechanism. I think that to a great extent, sensitivity in the brain involves this, and also involves something else that I'll talk about shortly. And this has been, these have been implicated in studies in animal models of MCS. We don't have any animal models of EHS, and we don't have any good data on this, I don't think. But if I had to bet, I'd bet this is involved in EHS in a major way, okay? So this isn't proof, but what it says is we have plausible mechanisms that can help explain this phenomenon, okay? We're not in a black box anymore. We have plausible mechanisms by which these things work. And so when, now, okay, so all of these similarities have roles in allowing each of them to produce these high-level sensitivities, what we call MCS and EHS, and one of those mechanisms is this one. The similar properties of the NMDA receptors and the L-type VGCCs are almost certainly behind these two types of sensitivity, okay? So I think, it's highly unlikely that the tremendous similarities of these two targets, that this is just coincidental. This has nothing to do with the mechanism. Quite the contrary. Okay, so again, that's not proof, but I think it's, I think that's what the evidence is pointing us. We obviously need a lot more evidence on this. Okay, so the other thing which is true, and this is something that I apologize for this because it's so complicated. This is something I've been working on basically for over 15 years. And it's a vicious cycle mechanism which I think is involved in many different chronic inflammatory diseases. And it's called the no-ono cycle because of nitric oxide, NO, and peroxynitrite, ONO minus. But you can see there's lots of other things that are involved. And the NMDA receptors are over here, and the VGCCs, which I just added for this purpose, are over here, and they both have very similar kinds of properties. And so the idea of this, and let me just say, there are actually 5 different complex cycles. Well, 4 of them are complex, 1 of them simple, believe it or not. And once these cycles get going, each cycle sort of amplifies the other, and you get this because they have elements in common. And so basically the idea of this is that once the whole thing gets going, the challenge is how do you downregulate it? How do you lower it? And that's the big challenge in terms of therapy. There are other things, of course, you can do which also may be helpful, but that's a key issue. Okay. And so again, the VGCCs and the NMDA receptors have very similar roles, not identical, but it's very similar roles here. And you have other things going on here. You have inflammatory effects over here. You have mitochondrial dysfunction, the dysfunction of the things that produce energy in the form of ATP over here. And you have a whole bunch of other things, which I guess I won't talk about here. Okay, so this cycle is predicted to be primarily local, which means based on the biochemistry of it. Okay, again, I'm not going to document this, but based on the biochemistry, you predict this cycle is going to be primarily local. So it can get turned on in different tissues in different individuals, producing different diseases. And so I think this cycle has a key role in both of these sensitivity diseases. And that the primarily local nature then helps us to understand why there's so much difference in the symptoms from one individual to another. But they all have sensitivity responses, but they're not all the same, okay? All right. So I think, I think maybe I think maybe that's all I'm going to say about this. But basically it gives you an idea that we're. Let's see how our time is doing. We're running out of time here. We've already run out of time, I guess. Let me just go through a few specific things here. Okay. So I mean, in EHS, I think therapy, and again, this is a view based on that mechanism, and it's not necessarily correct, but it's a sort of a best guess, if you will. And let me just say I'm a PhD, not an MD, and none of this should be viewed as medical advice. But, you want to lower the no-no cycle. There are a number of ways of doing that. You want to lower the sensitivity of the VGCCs, particularly the L-type VGCCs. And there are some ways of doing that. You can do it with fish oil. You can do it with other supplements. Gabapentin, I think, may be an attractive drug. Lots of times I think drugs are attractive, and then I find out, oh, they have side effects that aren't so good. But it may be worth trying. I can't tell you that for certain. And obviously avoidance. Avoidance is always key with these sensitivity. However difficult it is to do that, and I know it's very difficult, however difficult it is, avoidance is key. And I think you all know that who were involved in this. Okay. So I think one can develop objective tests for EHS based on those mechanisms. And okay, so I think what I should do now is, okay, so let's go to this, and then I'm going to talk briefly about something else. So in general, there are three main conclusions that we can draw from this discussion. One is that what's called the heating thermal SARS paradigm. SARS refers to heating effects of these fields of action of microwave and lower frequency EMF should be replaced by a VGCC activation paradigm. Activation of the VGCCs may not be the whole story, but it's clearly most of the story. Okay, there may be other effects that we haven't seen yet, but most of the things that we can see go through that mechanism. A large number of reported microwave effects then can be understood as being caused by what are called downstream effects of VGCC activation. And EHS seems to be very similar to multiple chemical sensitivity, with the targets of EMFs acting through the L-type VGCCs and the targeted chemicals working on the NMDA receptors. And so producing things like elevation of the no-no cycle and excessive long-term potentiation in the brain. Okay, so those are the main things, and I think maybe I better skip this, except to talk about it very, very briefly. I have a paper which I submitted just before I left the U.S. That is a critique of the report of the Canadian panel of experts, which came out earlier this year, which basically argued, well, everything is thermal. Okay, and so I looked at the evidence carefully in the report and documented various kinds of conclusions about it. And obviously, I think that it has major flaws. But one thing I want to say is the following. Karl Popper, who's one of the two most famous philosophers of science in history, talks about different kinds of evidence for testing various theories. Okay, and that's, of course, in science, what you do is you construct theories and then you test them by looking at various kinds of data. And so the strongest type of evidence, according to Popper, is evidence that shows that a theory is false, that a theory makes predictions that are not true, and you can test them and you show they're not true. There are literally thousands of studies on EMFs, as I said before, showing health effects at levels well within safety standards. It shouldn't be there. All of those, each of those, argues for the falsification of the current safety standards. The second most important kind of evidence are what's called risky predictions. And risky predictions are predictions which you make based on a theory, but they're specifically predictions that are unlikely to be made based on any other unrelated theory. And so confirmation of these then can be very important because of this specificity here between the theory and the prediction. The weakest type of evidence are what are called confirmatory tests, where you do studies and you say, well, I've gotten results that are consistent with the theory, but they may also be consistent with other theories, so they don't in any way throw out other theories. As far as I can determine, all of the evidence supporting the thermal paradigm is of the weakest type. On the other hand, as I've already stated, there are thousands of studies of the strongest type which argue against it. So I really don't see any, any substance to these arguments. It seems to me the whole thing is dead. How long it's going to take before it actually falls down physically, I don't know, but it will. Anyway, okay, so I guess I've talked about these already, so why don't we go on. I listed a whole bunch of flaws in the Canadian report, and I'm not sure I want to talk about some of these we've just discussed. One of the things is that it doesn't provide an objective assessment of the scientific literature. There's the literature they tend to talk about are things that support their point of view, and there's lots of things that they don't talk about which don't support their point of view. They argue, as other people have, there's no biophysically viable alternative mechanism. That's not true. They claim there are extensive inconsistencies in the evidence, and they throw out huge amounts of data based on claims of inconsistencies, and other people have done similar things. I went through very carefully the literature on what's called genotoxicity, DNA damage type studies, which they gave they gave primary literature citation. So they looked at real individual studies, and so you could look at the real individual studies and ask, what do they tell you? And they ended up, and the majority of them actually falsified their position. The majority of them showed real effects at low levels, but they took this whole bunch and they threw them out because they claimed there were inconsistencies. In fact, there are no inconsistencies in those data, none. Why? Why do I say that? Because they're looking at different cell types, and we know different cells are different, and they have different amounts of VGCCs, they have a lot of differences. They're looking at different fields, and they're looking at different endpoints. So all of the studies are different. You don't expect to see the same results if you do different studies. And so there's actually no inconsistency whatsoever in the data that they cite, although they claim there are, and they throw these things out because of inconsistencies. Okay. So let's just. I think probably I should quit at this point because we really need. Huh? No? You want to hear more about these things? What? Let me take a vote. How many people want me to go on? How many people want to start questions? Okay, go on. All right, questions? Comments? Okay, well, the majority has it that we got to, huh? No, most people want to do the other. So let's just go on. I'll do it quickly. I'll do it quickly. Yeah, well, something like that. Yeah, okay. Oh, actually, I'm pretty near the end here, right? Okay. Actually, I'm right near the end. Okay, so so one of the questions about this is, what about environmental effects? You know, how broad are these effects? Well, we know that there are VGCCs in most, if not all, multicellular animals, including things that are very different from us, like Drosophila flies, and one of the studies I cited was in mussels, which is a mollusk, of course, that we eat. And they all have VGCCs, and at least in mussels, they respond to EMFs. Okay, so so this is probably a general thing in multicellular animals. Plants have been shown to be sensitive to weak EMFs. Plants, as far as I can figure out, do not have VGCCs, but they have other voltage-gated ion channels. And so perhaps, and I say perhaps because I don't think there's any data on this at this point, perhaps the plants may respond through these other voltage-gated ion channels, and they may be sensitive to EMFs in that way. Amphibia, I think, are particularly interesting because they seem to be, it seems that for some reason their VGCCs may be particularly sensitive. And it's been suggested, and I say this is just suggestion, this is not proof, that these low intensity EMFs may be responsible for this worldwide decline in amphibian populations. So these are some of the things that may or may not be going on in the environment, but there certainly is a lot of evidence that a wide range of organisms are negatively impacted by these fields. So, okay, thank you. That's it. Yeah, and let me say, anybody who has any criticisms or anything, we're open to those as well.
Let me add that we tried to find, in the spirit of the ONNET seminars, to find some opponents. We tried in academia, in public administration, and in private enterprise. Again and again, we did not. So we have to do with ourselves, but I know there is some expertise here in this room. So, but first of all, questions for clarification and so on. So please, the word is yours.
Hello. Thank you, sir, for a very interesting lecture. Can I just ask, on the basis of your last sort of bullet with amphibians, like crocodiles and creatures that has been around for millions of years?
No, crocodiles are
Sorry.
Yeah, crocodiles are not amphibia, but anyway,
not, but
I don't know where they fit in this thing. Yeah.
But anyway, I'm saying that animals, or whatever,
Yeah.
that has been around for many, many years, now that we see that we have introduced this sort of effects on our existence, then we suddenly see a sort of decline in that existence. Is that what you're saying? Henceforth, we could substantiate the whole, this is to me this is a new evolving science,
It is indeed, and I have to say, one of the things, of course, you have to be careful about is not concluding that X causes Y because the two go together, that there's a correlation between them. On the other hand, there is, the reason I raise this issue with amphibia is there is evidence that the amphibia are particularly sensitive. And so, it's more than just a correlation. There may, in fact, be, mechanistic connections. That, again, is not proof. So, yeah.
Okay. My name is Ida Solheim. I want to thank you very much for an excellent lecture. I would like to ask you, to what degree does your theory match the mast cell hypothesis of Dr. Ollie Johansson, who is attending this meeting today?
Well, Dr. Johansson could probably answer that better than I can, but I think, there are these channels, I believe, in mast cells, isn't that right? Yeah. So it may be very much sort of, variations on a theme and of course mast cells produce a lot of inflammatory responses that could be quite important. So I think these are all consistent, It's just a question of what's the relative importance of this versus that, and we're still in the process of trying to determine that. I think is that fair? Yeah.
That's definitely fair, and just to add a little bit, I think you and Einar, you pointed to a very important factor here, namely that the other side seemingly doesn't give a toss about this or other findings, and that we need to get every player up on the stage, work together. And you and I, for instance, we have tried to get studies going to directly investigate whether, for instance, electro-hypersensitive persons do have alterations in VGCC systems, and it's just a matter of money. I mean, we do have the brains, especially your brain, and it's just a matter of arms and hands and feet and money to start studies to solve these issues. And as you so very rightfully pointed out, there are so many studies already that do fit together, but we need to convince the other side that this is important. And for many, many years and even decades, scientists have asked for instance, biologically based exposure standards. And it needs to be said that the ICNIRP, who has launched these technical guidelines, they have said that they were never ever meant to be used for medicine or biology, but all the authorities doesn't understand this. All the politicians and health officers and so on, they are looking around and they are finding things like the ICNIRP standards, the SAR levels and so on, and they are just not usable at all, and they were never meant to be. They are for technical measures, antenna production, etc., and we need to come down with other markers, which you so very elegantly pointed out, that we could even use these as markers as well as clinical markers.
Yeah. And thank you. Dr. Johansson has been a pioneer in this area, and his work is very important in this area, and I thank him tremendously. Let me just make one comment about this issue of biological measures, okay? And a number of people have argued, yes, we need real biological measures of damage. I think it's actually relatively easy to develop these. And I think you could do that by using cells in culture that have a lot of VGCCs in them and look at their responses to various kinds of fields, various kinds of frequencies, intensities, etc., and measure the response. And you could do that very similar to the way Arthur Pilla did his studies. Remember, just measuring nitric oxide, which is very easy to do. It doesn't take a huge amount of money to do this, but it takes something. Now, let me say I'm quote-unquote retired. I don't have a laboratory to do this, but there are many, many laboratories that could do this kind of work. And we need some funding for this, and it really desperately needs to be done. Okay, so let's go.
My name is Tove Steinbo. I don't know much about this, but I have followed and been interested in it for many years. For instance, the microwaves. And if I'm correct, many years ago, I read something about Russia, and they were not allowed to sell micro ovens in Russia. I don't know if that's true, because the science there found it was not good for humans, to say it that way.
Let me just, you're right about the Eastern Europeans had, and I believe still have, much more stringent safety standards than most of Europe and the US and Canada do. Yeah, in that sense, they were pioneers, and it's unfortunate. Let me just say one thing about that. It's been stated that our exposure to these fields is about 10 to the 10th times what we were exposed to in earlier human evolution, okay? So there's been a huge increase in exposure. So 10 to the 10th is what? I don't. Do you use billion the way we do in the U.S. or the way the UK people do? So about 10,000 million times as much exposure now, and it keeps going up every year as new devices get introduced. So there's a huge increase, and it's really to do this without any sense of the dangers that that we're accruing makes no sense to me.
Heiko Santelmann, hello. Thank you very much for this excellent lecture. I wonder if you can help me with a puzzle. I've seen so many times in my family practice that people with electromagnetic hypersensitivity or fibrillations get rid of their symptoms by high doses with antihistamines.
Well, so that would relate to the role of mast cells, I guess. You know, I think that's, yeah.
Thank you.
Is that right? Yeah. Okay. It would relate to the role of mast cells. I mean, that would be an argument for mast cell involvement.
Just very quickly, we found earlier that people with the functional impairment electrohypersensitivity do have a very high increased number of mast cells in their skin. And also when we subjected normal healthy volunteers to exposure to ordinary household television sets and ordinary household computer screens, you got a very dramatic increase in the mast cells without any subjective sensations, as if you would do in any classical radiation damage. This is what you would have seen in the workers near to Chernobyl or Fukushima due to the radioactivity. You would have seen that in the early radiologists that were exposed to X-rays without understanding what's going on. You would see that in high exposure to radar in the 40s and 50s before safety standards were developed, etc., etc. But we only put them in front of television sets and computer screens and still saw this. So there is a direct link, and it fits very well with what we have just heard presented here in this excellent lecture as well.
Thank you.
Hi, thank you for the lecture. My name is Frederick.
Sorry,
over here.
Oh, okay.
Yeah. I have a question for you. You said one of the things that we could do is to lessen the damage in our body of microradiation is to avoid the exposure. But since we cannot avoid exposure in the cities, and most of us live in the cities, what is it that we can do? Has earthing anything to do with it? Maybe some other devices, or can you answer on that question?
I think earthing may have something to do with it. Let me tell you why. And this is a hypothesis, okay? I'm not saying that this is established. But whereas, I said before that in general, most pulse fields are much more biologically active than non-pulse fields. But the very low energy, low frequency fields that come out of the ground are very low frequency. I guess they're around, what, 8 hertz or something like that.
7.8.
Okay, that's pretty close to 8. And there are reports that these very low frequency pulsations actually lower responses. So if that's true, and I'm not saying it's true, this interpretation, it may be that earthing actually does lower the sensitivity in that way. That when you pick up these very low frequency fields from the ground, that they may lower. That's speculation, but it's reasonable speculation. Huh?
How can you do earthing in practice?
You can walk barefoot. You can walk with shoes that are not insulated, not rubberized, which I always have on, I have to say. You can actually get devices that come out of the shoe and go around that conduct electrically, and then you can earth in that way. So there are ways of doing it, and again, this is speculation. I don't know. I mean, it's just. But the earthing thing was something that I was interested in, and then I found out that there were these effects of these very low frequency oscillations, and that they actually inhibited. Which is, it just seems like it's an interesting view. Again, this isn't proof, but it's something that might be worth trying.
But what else can we do?
Well, there are lots of things you can do. I mean, there are many things you can do. For instance, in your home, you can put shielding on the walls. You can use curtains that help shield yourself in your home.
And that's proven to work.
Yeah. Oh yeah. Yeah. You know, you have problems. You know, for instance, if you're living in an apartment building, and your next door neighbor has Wi-Fi, you're getting it through the walls, right? But you can use one thing you can use is graphite paint. It's a black paint. You can paint the walls black, and then you can cover it up with something that you want to look at, not the black, and it'll help shield you from from your neighbor's Wi-Fi. You can do, obviously you don't want to have Wi-Fi in your home. You don't want to have cordless phones in your home. You don't want to have cell phones. But if you have those cell phones, there are ways of using them more safely. You can use headsets. You can put them on speakerphone. There are things you can turn them off when you're not using them. So they're on airplane mode, so they're not actually irradiating during that time. There are lots of things you can do. One of the things that is, one of the things that I think should be done, people have laptop computers, people have tablets, right? These things are irradiating out the back. You sit there with your tablet on your lap or your laptop on your lap, and you're getting irradiated, right? There's no reason why you can't put some shielding on the back of these things. The companies ought to do it for you, to protect yourself. I mean, we have studies where men put their laptops on their lap and with the Wi-Fi on, and their fertility levels go way down. So there are all these things that can be done. They're not hard to do, but there are a lot of them. There are many of them. There's no simple way of protecting yourself from everything. And we're in a dangerous world.
The next question here.
My name is Raphael Kleiman. I'm electrosensitive, and for the past 6 years I've been mostly helping other electrosensitive people. We're having a little shop 5 minutes from here with shielding devices and measuring devices and consultancy work. And by the way, I experienced the same thing as you're experiencing here. We organized 3 international conferences about electrohypersensitivity and so forth, and there was no press reaction at all, and we were not able to really reach out other than to us other electrosensitive or sensible people.
Yeah.
I have 2 questions. Can you relate your research in any way to the research that is behind the Nobel Prize in Medicine of this year about the magnetites in the brain? And how do you relate your research to what Professor Warnke was doing in Germany, showing that bees die and lose their sense of orientation because of mobile radiation? It was actually in his research that I first read about yours, because he's using parts of that mechanism for explanation.
Yeah, I haven't looked at the bee issue, and it's no doubt something I should look at, but there's only so much time. But obviously, what you suggested suggests that the bees are involved. I mean, we know these channels occur in insects, and so it's quite possible that they're going to affect the orientation of the bees. Well, the magnetite thing, I have to say, in mammals, which obviously are the creatures we're most concerned about, since we happen to belong to that group. I haven't seen any evidence that the magnetite is involved. Now, that doesn't mean that there isn't an involvement. It just means I haven't seen any evidence for it. My understanding is that migrating birds, there's good evidence for the involvement of magnetite, and there may be in bees too. I don't know. But of course, the nice things about the studies of the VGCCs is we do have these calcium channel blockers, so we can study those roles, and. Yeah.
First of all, I'm Peter Keroff. I'm an MD and a PhD and Professor Emeritus, like you are. And first of all, I'd like to credit you for your talk. It's an excellent talk, and the people in the room should actually appreciate that. I'm also the only research ombudsman in the whole Norway at the University of Oslo and the Oslo University Hospital. So I've been through the work of many people throughout the years. I'm impressed with the way you choose your words, because they signify the man you are actually, and people should understand that. And I also like to give credit to Flydal for arranging this meeting, which is an extremely important type of meetings, which we lack in many places in Norway, I think. So one should probably try to pursue these ideas for the Research Council in Norway. And see if people there will come up and stand up for money for research on the VGCC. It's hard to remember the synonyms, but that's what I mean. Because this will be extremely important that we do proper research on. Thank you.
Yeah. Thank you, and thank you for coming. I think it's very important that that we have academic involvement. Let me just say, I went back to my university last December for the first time in a number of years since I retired, and gave a talk on this topic, and I also gave another talk on a different topic. And they asked me who I wanted to see. And I listed among the people I wanted to talk to were six of the people in the electrical engineering department. I expected they would be skeptical. I expected some of them would be hostile, but what I didn't expect was what I found, and that is that none of them were willing to talk to me. So, we still have lots of battles. It's not uncommon in science for people to break down into opposing camps, and it often takes quite a while before those barriers break down. But what is different about this, in my judgment, is there are so many published studies, each of which falsify the current safety standards, and you have these people ignoring all of them. Thousands and thousands of studies. I mean, it's just incredible.
My name is Kari Reksten. I'm not a medical expert, but you mentioned a lot of diseases, but you didn't mention autism. And it has been claimed that there has been an incredible increase of autism, more or less parallel to the microwave increase. And I read once something about elements that cannot escape from cells of autistic people, and this sort of made me I was reminded of that when you talk about these ion channels. Is there a link there to the autism?
Yes, there is a link there. Let me give it to you in a brief form. We know that excessive activity of these channels can cause autism. That doesn't tell you that this is a general cause of autism in the wider population, but there is some evidence that supports that view as well. Okay. There is, however, an alternative explanation, and that has to do with chemical exposure. I think it's clear that both of them have roles. My opinion is that the EMF role is probably stronger than the chemical role, but I could be wrong about that. So I do believe that these are involved in causing the autism epidemic, but whether it's the primary cause or a secondary cause is at least somewhat uncertain. Okay, so that's sort of the short answer to the story.
Hi, my name is Manjit Singh, and I would like to thank you very much for your very nice, interesting, and very important talk.
Thank you.
We need people like you who are respected, who have a high level of education, who can do some credible, respectable research. So we can change the picture of a world in this sense. I would also like to say this, there was a question about earthing. I have tried this. I am extremely, if I should say that, sensitive to electromagnetic field, especially the magnetic field and the pulsing magnetic field. That is a big problem because there is almost nothing that blocks that. You have to do a lot if you're going to do that. In my case, I have measured that it's the amount in, let's say, 2 milligauss that is enough to provoke symptoms.
Yeah.
It can do different things. For example, it can pinch my body like needles. If somebody is putting needle into my body, and it can make my head tense like a balloon filled with lots of air. So I have lots of trouble then moving my head because that is very painful. And also it makes me very restless. So earthing, it may be that what you have voltage introduced into your body because of this line voltage, it can remove that. Because once you connect your to the earthing, the voltage about 5 to 10 volt that goes down momentarily. But I don't think it can do much to the effects introduced by magnetic fields, for example. Thank you.
Okay. So.
My name is Sissel Halmer. I think thank you very much for coming to Norway, Professor Pall. And what you have told is really complex combinations here, and it's really difficult to understand what's happening in the body. We all have different symptoms. What is important for me is we have to do something with the sources of the radiation. We can't treat all the symptoms in all the different people and the bees and the insects and the animals and the plants and the trees. We have to do something with the sources. We have to get rid of all this radiation and the fields that harms our body. And there are alternatives, so we need to work together with the developers to have other ways of doing the communication that we want to have. I agree that I would love to have all my gadgets and get rid of the symptoms, but that's the easy way out. We can't solve all the problems with having different bits on the mobile phones and earthings and fish oils and all the other things. That's taking away the symptoms. We have to do something with the sources.
Yeah, I agree.
My name is Greta Winning. And what I'm interested in is because things are the way they are right now, and I'm interested in finding out what can I do in my everyday life. Fish oil was mentioned. What about antioxidants?
Antioxidants.
Fresh fish, vegetables and fruits, for instance.
Yeah, and herbs.
Yes.
And I think. I have a paper that's been accepted but isn't out yet on a regulatory response, which is focused on what's called NRF2, NRF number 2, which produces absolutely incredible protective responses. And I think that I could spend 2 hours telling you about it, and we don't have time. But there is an incredible. I think raising things that raise NRF2, and there are many nutritional components that do that. There are also things like exercise and low-level oxidative stress, which produces a protective response. These things all can be useful, and to raise the levels and get this protective response. I think this is going to be one of the major issues in the next few years. Most people are not aware of this, and the people who are mostly know the old data, and there's a lot of new stuff on this. It's extremely, extremely important. So, anyway, but let me just say again, I'm a PhD, not an MD. None of this should be viewed as medical advice, okay?
Yeah, I have just a few quick comments, not to you, Marty, but to others, so you can rest a little bit. I think what Cecil Halmey brought up is extremely important, that we really need to ask ourselves what's for tomorrow. And I coined many, many years ago, actually in the 80s, the need for tomorrow's human-friendly technology. And of course, as a Swede, I want Swedish companies to develop and sell this, because then Sweden will be much richer than Norway is right now. But being in Norway, maybe you want to do it. And also, you know, I feel very strongly that actually the war is over since a long time ago, and you hinted at it. And together with Einar Flydahl, we wrote this year an article. Einar was actually the brain, I was more the kidney in this writing duel, and where we pointed to that it's actually over, and I think it was over already 10-15 years ago when, for instance, the insurance companies said, no, we will not protect from damages from electromagnetic fields. At the same time, the telecom operators also said no in their licenses and whatever regulation they had with countries. They said, no, we will not have any form of liability or responsibility for this. And as you know, also recently, the manufacturers have been extremely intelligent, telling you, which people never read, but you need to have your tablet or a mobile phone at least 1 inch away from your body, which makes it impossible to use them. And in a court of law in the United States, for instance, the first question from them would be, which hand did you use? Well, I mostly used my right hand. Well, you couldn't. We said you need to keep it 1 inch away from your body. So it's extremely smart, you know, but it also is very telling in a positive way. The war is over. You have already won this, you know, but it will take months, years, decades before it seeps through society. And I say again, I do hope Swedish companies will understand this.
No, I thank you. Let me just, I think, you know, there are a couple of things I just want to comment, because I think, you know, you're absolutely right. I think, first of all, we need one smart company to say, okay, we're not convinced there are any health effects, but we know a lot of other people are concerned about it, so here are the things we're doing to make our products much safer, you know, as safe as we can make them for this. I think you have one company that does this, they would prosper, and there would be, you know, there'd be a huge market for them. The other thing I want to say is that in the U.S., there was a study done where houses that are near cell phone towers sell for much less money than houses that are elsewhere. People know that this is an issue, even though the media have completely ignored it, or almost completely ignored it. There was actually a good article for this meeting that was published. So it's not complete, but so even though the media have been ignoring this, people know about it. You know, there is an understanding, and I think you know that you know, this is all a house of cards. And at some point, it's just going to blow down. The question is, how many people are going to suffer unnecessarily before that happens?
Thank you. I wonder if you can relate your research to the question of light pollution. Like in my therapeutic practice, both with clients and customers, and on myself actually, I experience much more reactions on light from computer screens, even on large distances. Light sources, not only the so-called energy-saving bulbs that also have mercury, but even the LEDs and different light sources. And the symptoms are pretty similar to what I experience when I'm exposed to, let's say, a mobile radiation.
Well, of course, I guess the simple answer is light radiation is also an EMF, and it's a non-ionizing one, so it may act in the same way. But I can't really... But I think it's also true that there are mechanisms which make people's eyes hypersensitive. And whether that has anything to do with this, I'm not sure. Anyway, okay.
I am a worried grandmother. My name is Elfrid Hovden. I had planned to ask about collapse disorder, but I refuse now. But I will only say thank you for coming here, and you must still keep alive. Come back.
Thank you.
We have just written actually a commentary about the coronary collapse disorder. That is a very interesting phenomenon too. But I want to comment upon the light question. As you know, this year the Nobel Prize in Physics went to the inventors of so-called blue light, and especially blue light, which is a component of, for instance, computer screens and mobile phone screens, has a very strong effect on your body, especially on the melatonin content, which in its turn has dramatic effects on the metabolism. And now we are talking about the fat explosion, the obesity explosion, diabetes, and a lot of other issues. So maybe in 20 years' time, this year's Nobel laureates in physics, together with Thomas Alva Edison, will actually have to go to jail because they ruined public health. It is ironic, but it's very interesting to think along these terms, you know. They do invent things, but are they really natural for us? And of course the answer is no way.
I want to say thank you. My name is Annette Kamfjord. I'm not a doctor or a specialist in anything, but I'm very interested in the topic, and especially for the generations to come. What about children and babies who are exposed to all this? And with all we know they're growing and the cells and all that stuff. How many generations do you think it will take until these serious things are sinking in and we're doing something really serious about it? Thank you.
Well, I hope in terms of generations that it's less than one, but I can't guarantee anything. Let me just say about children, there is evidence that cells from young babies or baby animals, for that matter, are more sensitive to these fields than cells from adults. And there's some information about the probable mechanism of that difference. So this is of concern, and this obviously may relate to the earlier question about autism, but it can also relate, for example, to the fact that there's good evidence that childhood leukemia can be caused by EMF exposures, but in general adults the evidence is much weaker. So that may help explain that difference.
Thank you. My name is Thomas Middleton. I am chairman of Norwegian Folkets Strålevern, Citizens Radiation Protection.
Ah,
yes.
Okay.
You are referring to thousands of studies showing adverse effects. Still, we are told the old story about industry and authorities all over the world saying there is nothing to be afraid of. How can this happen? What happened to science? Is it all tobacco science today?
Well, you know, obviously there are a lot of people publishing these studies. Let me say, I said there are thousands of studies of biological effects. Some of these are therapeutic studies. They're not all bad, but you know, but there are roughly 1,000 studies on oxidative stress. There are roughly 1,000 studies on calcium fluxes and calcium signaling, and there are many others of various other sorts. So there are a lot of studies out there, and obviously lots of people have been doing very good work on this. You know, the question I think you ask is why is it that these expert panels over and over and over again say, hey, don't worry about it, when there's all these evidence. There's all this evidence that shows that that's not true. Yeah, it's very disturbing.